All right, what's up, everyone? I hope you guys are doing good. Sorry for delaying this to 7. I got a little something else came up earlier, and I couldn't host this at 6. So I hope that wasn't too big of an inconvenience, but I'm here now. And I believe this is just gonna be going. We're just gonna be doing a preliminary look at this hash map assignment you guys have due in 2 days. Definitely gonna be a breath of fresh air from the AVL tree assignment. In my opinion, it's definitely much easier and more straightforward than the other one. So this one I hope isn't too much of a challenge. Um, just to start things off right off the bat, I'm gonna share my screen here. And again, or this is actually going to be recorded this time. Apologies that I forgot to record the AVL tree starter assignment, but this one will be recorded for future reference. So to start, we're just going to take a very high level overview of the starter code and what exactly it's saying, or what exactly it's saying, and what we're trying to do here. So the background story for this assignment is that we're creating a password manager, and if you think about it, a password manager, like the whole point of it is it's kind of just like a hash map where for each website, um, it links to its particular password, right? So it's like a one-to-one relationship of these websites to a specific password. So this is it's very efficient to implement this specifically as a hash map, which you'll be doing in this assignment. The actual hash map, or the inner workings of what's going on with this password manager, naturally is in the password manager class. As you guys can see here, this is where you'll be writing all of your methods. And what I wanted to point out was the just taking a look at the structure of where the hash map is stored itself. It might be a little confusing because, for this particular assignment, we're not using any built-in like Java implementation of a hash map. We're not saying like passwords equals new hash map, right? We're kind of doing this all like indirectly, right? So the hash map, actually, we're going to be storing it in its actual original form, which is literally just an array of stuff, right? And so if you notice here, we have this kind of array of this account object called passwords. And then when we construct the object, we notice that this array is going to be of length 50, right? So you might think, like, what does this have to do with a hash map? Well, if we pop open the account class here, and the semantics might, oh my goodness, the semantics might be a little confusing because it just says like account. You might expect it to be just like, oh, each one of these things in the array is just one individual account. Well, actually, if you look at the account class, well, you're going to have the website and the password. Okay, that makes sense. Notice here, website is of type K. This is short for key. Remember, back to generic types, right? So this is the key, which is the website. And then the value is the password. Again, this is the generic type V, standing for value. That just ties back to what we said earlier. Anyways, notice how this account object, it actually has this next parameter right here. You guys see that? So actually, if you remember back to towards the beginning of the class when we talked about linked lists, this is exactly what kind of like a linked list looks like uh, when you implement it in Java. If you think back to like the linked list assignment, you would have like the data it holds, and then you'd have the pointer to where the next element is, or the next account. So with that, you guys see that this is actually not just an array of individual accounts. This is an array, a 50 length array, mind you, a 50 length array of linked lists. So that actually makes more sense, right? Because what we're going to be doing, if you guys remember back to class, back what you learned in class, we're going to be using a hash map. A hash map. I don't know what it's called. Just like a hash map configuration called chaining, where even though we have a limited amount of spots in the hash map, we can still store a limited amount of things if we just chain the things in one space together. Like if we just add the thing we want to add in to the end of the chain. And I'll pull up my iPad here in a second to show that in more detail. But with that out of the way, that's the basics of how this is going to be formatted. So the passwords is what's going to store the actual information for the entire assignment. One other thing I wanted to point out is if you go to the assignment, I don't remember exactly where it says it. Okay, so do you see here it says the hashing algorithm will be using this hash code method. So if you notice, a hash code method will return exactly an integer that is computed with a built-in hashing algorithm. So just in other words, what that means is you guys won't be having to create the hashing algorithm from scratch. Java has a convenient way of doing that for you. But this is where the magic is going to happen, right? This is where you're going to say, okay, I have a new website, a new key, and I want to know exactly where in the hash map, aka this array of linked lists, which spot to put the new account in, right? So it's really convenient that this just returns an integer, right? Because indexes are just integers. Um, but you might notice, like, okay, if we pass a key into the hash map, right? So I'm gonna instead of just talking about it, I'm gonna write like the helper method, which you guys might want to follow along with. So let's say like I had just this helper method. Um, I don't know, find index, and then right. So what we're saying is that if we take in a key, what we're saying is we want to take this key that's not necessarily an integer and turn the k key into an integer 0 to 49 inclusive, which will be the place we will put new stuff in, right? So that's the goal of this function, right? So if you notice, all we got to do is just do hash code key, because hash code just returns an integer and it just takes in an object. So basically it takes in anything, right? Wait, what's going on? Expected 0 arguments. Oh, shoot. It should be like this. Okay. So what we have right now is almost correct, right? Because, okay, we're going to go from this key value, which is not necessarily an integer, and we're turning it into an integer. Okay, that's good. That's like what an index type is. But another core problem is that like our list here, or our array, which represents our hash map, is only of length 50, right? What happens if this integer is greater than 50? What are we going to do about that? So there's actually a pretty simple fix to that. If you guys remember modulus division, right? Essentially, this just divides it by 50 and just returns the remainder. So if you think about it, if we just take this and then do mod 50, if the number was to be greater than 50, right? Say it was 59. If we did 59 divided by 50, the remainder would be 9. So then instead of being a number which is outside of our range, 0 to 49, that 59 thing, if we just mod it by 50, it'll always be within our 0 to 50 range, right? So in short, that's basically the whole what the whole like hashing algorithm is. It's literally just going to be using it's literally just going to be using this hash code method and then just using this clever trick with the mod division in order to keep that within the proper range. Otherwise, you're going to go over bounds eventually, because we only have 50 spots again. But yeah, so that's the hash index. I'll just give this one to you guys. Shouldn't be too hard to understand, but this will just take a key and then just map you exactly to where in the account you want to look at, right? And for more specifics with the actual hashing itself, if you guys are at all confused about that, I'm gonna just go over it very conceptually on my iPad here. Let's see if this will work. All right, can you guys see my screen? Can someone let me know? It should just be like a white screen right now or something. Okay, I assume that means yes. Sweet. So, what are we going to be doing with this? So, okay, first of all, let's just draw the array itself, right? I'm going to draw it like this. Say we have this array. I'm going to draw it kind of like vertically. And then remember it had like 50 elements, right? So we're going to denote each index in the array. So 0, 1, and again, this is a little lopsided to how you normally see an array, but just bear with me here and it'll make sense. 3, right? And then the indexes go all the way up to 48, and then finally like 49. Okay, so we have an array with 50 elements, right? And remember, the data type in the array, we saw that the account data type, or the account object that was defined, is actually defined as a linked list, right? So in each one of these spots, there could just be like a whole linked list in there of just like as long as we need it to be. Say in like the 0th index, there was just this whole chain of accounts in there. Or maybe in like the 3rd index, there's like this in there, and you know what I mean. So why are we using this linked list? Like, why not just store the account straight up in the 50 spots, right? Because you just kind of think that this should just make it more complicated, right? Like, why not just store the direct thing in there? Like, that's what we initially thought it was. Well, I'll give you this case, right? So think back to that hashing algorithm we just wrote. Oh, sorry, someone just sorry, let me reshare. But as I was saying, right? Think back to that hashing algorithm, right? So it'll return um some index, right? We don't know exactly what that index is going to be, but we just know that like for each key it'll uniquely map to some index. Why is it suddenly being weird now? Sorry, it's like not connecting. Uh, oh geez. Will it work now? Sorry, I have no idea what just happened. I just unshared my screen and now it's like, oh, and the person I let in just left anyway, so I just did that for no reason. It's pretty cool. Yeah, I don't know. It's not working. I might just have to do without for now. But apologies for that. Just kind of like think of this in your head, right? So if I'll just type it out, I guess. So like if we passed in like we had a key and like the key was like for the facebook.com website, okay? So if we want to store a password for this key, okay, let's say the password was like, I don't know, just password. Okay, this is just like an example of us inserting into the hash map, right? So let's say that if we did find index facebook.com, the result would be 4, right? I don't know. So 4. So in the passwords array, at this like fourth element, if there wasn't already a linked list there, then we're going to have to add in an account object. Because remember, if there's nothing already there in an array and we initialize it like this, it's just going to be null. So it's either we have to initialize the linked list in this spot 4 in the fourth element, or if there are already elements in that fourth index or whatever that was returned here, if there are already elements in there and there's already a linked list, what you're going to have to do is you're going to have to traverse through the linked list and then add this facebook.com and then password account to the end of that linked list, right? Because that's just the basics of a linked list, if you guys remember. If you want to add something, you have to traverse and then go to the end and then just slap it in. So that's what you're going to have to do. And this makes sense, right? Because, okay, say we didn't want to use this linked list thing, right? We just want to store one account for each spot, which makes sense, right? That seems simple. But say we had a key like twitter.com, right? And then, I don't know, the password was Apple. What happens if we do find index twitter.com? Okay. And then this index also returns 4, right? Because if you think about it, this find index method, it's not guaranteed to not return the same index, right? There's way more like different key possibilities than 50, right? So like consequently down the line, there's eventually going to be 2 keys or 2 websites which return exactly the same index. There's only so many spots in the password manager. There's only 50, right? And you're going to have more than 50 kinds of websites, right? So you're going to come across a point where if you just tried to store one account in each spot in the array, you're going to either have to evict that one out, or again, you can elegantly solve this with just a linked list, allow multiple things to dwell in one spot. So that is why we're going to be using this kind of linked list structure for each spot in the hash map. Hopefully that makes sense. Like different keys, in short, different keys can yield to different index hashings. I mean, same index hashing, sorry. And that means that multiple things are trying to get into the same spot. So instead of like having some complex way of circumventing that or preventing that from happening, let's just allow that to happen, right? Just allow multiple things to live in one spot. So that's what's really nice about a linked list. So anyway, that should be all the conceptual stuff out of the way. The high-level conceptual stuff. Hopefully that somewhat makes sense. Does anyone have any questions so far before I get into some more of like the pseudocode stuff? Okay, should be good. With that out of the way, since we know the basics, I'm just gonna go over some like of the basics of what you guys are looking to do for each method. I'm not gonna write any code because I'd just be giving away the answer, but I'll be giving like a general idea of where you want to start off, and hopefully it wouldn't be too crazy. So the first thing we're asked to do is fill out this put method. Self-explanatory. It's pretty self-explanatory. Sorry. Here it says the put method creates an account object using the key value pair and inserts the object at the appropriate index based on the hash of the key. Of the key. Wow. Who's writing this? So yeah, if that didn't make sense to you, basically this is just the insert method into the hash map, right? So let's just follow the steps it asked for us. So first step, create an account object with the key value pair. Okay, hopefully this isn't too bad. I'll just give this one away. So this would just basically be as easy as just going in and just creating some kind of placeholder variable. New value equals new accounts key value, right? So this is what it's saying. It's just like we're creating some variable which we're going to eventually trying to add into our array or our hash map, right? And then 2, Okay, with that out of the way, we need to know exactly where to place this, right? We have this key here, right, which is nice, but a key is not an index necessarily. It's this generic type k. It's not necessarily like an integer number. So we can't directly go and just say like, okay, passwords at key equals new value, right? Because key is not an integer. This would not work at all. That's the whole point of creating this find index method. So the second step would be find the index, the integer index where this key belongs, right? So in other words, you're going to want to use this find index method, or this hashing method that we wrote, to convert this random object key into its unique mapping to an integer, right? So it'd just be something like that. Pretty easy. And then once you have that, you have an index of where you need to put it. Okay, so you might think passwords at, let's say we called it index. Okay, all we got to do is just set it to new value. This is not necessarily the case, right? Because if there's elements in there before, you just overwrote all of them, right? That's not how you would add to that spot. Remember, each spot is a linked list, not like its own individual thing. That's very important to know. So the third step, you have two cases. Case one is where the value at this spot is null. Then just initialize the spot. Okay, so this makes sense, because if there's nothing already there, there's no hash map, then we need to create something there and like kind of start the chain. But if there already is existing elements at this index, then what you want to do is then iterate to the end and then add the new account, right? So just think back to like the linked list assignment. You can look back at it for reference, but basically remember how you added to it is like you keep going to this next value. So say there's like this head value account, and at each value you can look at the next one, right? So basically you're going to want to implement some kind of for loop or while loop to continuously look into the next and the next and the next until eventually this next is pointing to a null. And remember, guys, when the next is pointing to a null, that represents, okay, it's pointing at nothing else. Therefore, this current element is the last element in our linked list. And then at that point, that's when you're going to want to do the update. So hopefully that shouldn't be too bad. So that's just like the insert method. Get, again, pretty self-explanatory, returns the value associated with the given key. So again, as you might have guessed, we're going to be involving that hash method, or what we called find index method. Same thing. Use the hashing method to see which linked list the key resides in. So the hashing method won't be enough to exactly locate where the element lives, right? Because each index is not pointing, I've been repeating this a lot, but it's not pointing to one account. It's pointing to the linked list where the account lives, right? So it's like we went to its neighborhood, now we got to find its house, right? So we found the linked list which the key resides in, which is nice. Okay. But then there's another step. We have the linked list the element of interest lives in. Then just iterate through the linked list until, until you find the element you are looking for. So yeah, it's not enough just to find the index which it lives in. You need to uncover that that underlying linked list, and then it's basically just traversing linearly through that linked list, searching for where this key lives, right? So just keep in mind, again, linked lists, there's no other way around searching it easily. You just have to brute force search from the beginning to the end. It's a big drawback of linked lists. Just kind of how it is. So again, you just like similar to how you iterated through this, you just probably do a while loop or for loop and just iterate to where you need to go, right? Okay. Size, it tells us this will return the number of key value mappings in the map. Okay. So this one, unlike this like get or put, this one won't really involve like the hashing method, which should make sense, right? Because if we're looking for the size of the entire hash map itself, we're not going to be looking for any particular index or elements. We're going to be looking at all the elements, right? So this simplifies things a lot. So we're going to loop through all of the indexes in the passwords array. So we're going to be looping through all of the indexes in the passwords array, right? So each index contains some linked list or nothing. As we pass through each index, write logic to measure the size of each linked list we come across. So in other words, we're going to be looping through what? An index from 0 to 49 inclusive. So we're just going to be going through every single spot, every possible spot in our linked list array. And in each spot, there could be a linked list in there. And then basically, we're just going to be measuring the length of each one of those individual linked lists until you get to the end. And that's how you're going to size up the whole thing. All right. Key set returns a set of all the keys contained in this map. Kind of similar stuff. If you guys aren't aware of what a set data structure is, if you guys taken discrete math or something like that yet, it just relates to like a mathematical set, or in other words, a set is a collection of things in which there can be no repeats, yet the order doesn't matter, right? So basically it's just listing like what the unique keys are, but not in any particular order, if that makes sense. This one shouldn't be too bad. Figure out the documentation for the Java set data structure. So yeah, this is, as you see here, this is returning a set. This is a built-in Java data structure, and there's just like a few methods you want to be aware of. In fact, I'm just going to look it up now. Java util set. Right, so you can just go to this documentation page. There's only like a few methods you need to be aware of, especially this add. Since a set has no inherent ordering, like adding to a set is literally just as simple as just calling this add method, right? Because you're not adding it at an index, right? There is no indexes, there's no ordering. So what you're going to want to do is you're going to want to create like an empty set object, this kind of set object. Create like an empty one of those, and then literally like how we did for size, iterate through every index in passwords and every linked list we come across, and add all the keys we see to the Java set we made, right? So should be very similar logic to the size. It's this kind of thing where we're going to be glancing, or we're going to be passing by every key value pair or every account in the entire hash map. And it's literally going to be that same logic where you're iterating through every index, and every index reveals an individual linked list in there, right? So each index has a linked list. Just go in there and put the keys in the set. Another cool thing to keep in mind is, like I said, sets inherently do not allow duplicates. So you don't actually need to check for duplicates when adding to a set. If you try to add a duplicate into a Java set, it just won't happen. So it takes care of that for you. So that's one less thing you have to worry about. Remove should be pretty easy. It's we're going back to just like using the hashing method to find this specific element. So, spiel like use the hashing method to find the index where the key resides. There is a linked list. Search through the linked list linearly until we find the element we want to delete, and then finally delete the element. Right? Should be very similar to like the insert or the get with just one extra step. However, it's going to be a little more involved because note removing requires us to keep track of a previous pointer. So be sure to keep track of that, right? Because when you remove, when you want to remove an element from the linked list that you're currently on, you're going to want to look at the node that was right before it, because you can set the node right before its next pointer to the current node's next pointer, right? It's that whole thing where you jump over the node where you want to remove. So just keep that in mind. Should not be hard at all. That's just one extra thing you need to do. And finally, I believe this is the last one. Yes, these are written for you. So the last method you're going to have to complete is this one called check duplicates. Let's see what it does. Returns an array list of the website names that have a password matching the given value. Okay, so should be super self-explanatory, right? I'm literally just going to, I don't know, go through each index in the passwords array. Because we're not looking for a particular element, we're going to be just linearly searching through all the elements. So it's that same whole thing with the other two methods. Go through each index in the passwords array. Go through each linked list for any account that matches the value. Add its website name to some collection to keep track of. So in other words, same thing where you're going through every index in the accounts or the passwords array, looping through each one of its linked lists, and then seeing where the value matches, right? And then you're going to be returning this list of K, which is, in this case, for this assignment, is the website names, returning a list where we find that value. One important thing to know is note no repeats. No repeated websites are permitted, I believe. So no repeated websites are permitted. There are several ways you can tackle this problem. The way I did it back when I did this assignment, I found kind of easy was actually just create this Java set. And then just like whenever I found a matching element, I literally just use like .add to the set, because it takes care of duplicates for me. Because whenever you try to add something with a duplicate, it just like won't add it. So I did all that, and then there's like some way you can convert. There's some way you can convert a set into this required return type list, which takes like one line. That's one way you can do it. Another way is you can literally just like create a list object with all of the stuff, with all of the keys, and then just add it all in without checking for duplicates, and then like manually go back later and remove all the duplicates. I don't know if there's a built-in Java method to do that. If you find one that works fine. Again, this is totally up to you to try and figure out how to do. It doesn't matter how you do it as long as it passes. But yeah, that should be all of the main logic methods you guys need to implement. And then I believe there's this like other weird part where there's like some user interface. I won't go into this in too much detail. It should be pretty easy. It's just going back to like the system.out.println and like the scanner stuff. You guys should be pretty accustomed to that from like the first two assignments. But yeah, it's literally just a repeat of that. Um, just like kind of look at the example usage and then just like try to mimic your code like that and like try mimicking these kind of inputs that is used in the example and seeing if it matches. Make sure that you don't add any like extra stuff that wasn't said in the assignment. I tend to see that a lot. It's like not necessarily your fault at all, because like it's intuitive to think that you'd want to add like some extra like words or fluffing to make it like more friendly to a user, right? Maybe like after here it would be like, please enter a new password or something. Please don't do that. I know it makes sense to do that, and I would definitely do that if you were like making this for some commercial purpose. But for the purposes of the assignment, copy exactly what's going on and with what it says up here, down to like the case sensitivity and the spaces. That's a big one. Make sure there's no extra spaces at the end, because you'll be on like a wild goose chase trying to see where you went wrong, and it's literally just a space at the end. Just make sure like the first time you're going through writing like the print lines, you you could literally just copy and paste it. I don't know. Just literally make sure it's written exactly the way it wants you to. All right, and that'll save you a really big headache. Um, is there anything else? Yeah. Other than that, I hope that all makes sense. Uh, just implement these methods and then like the main method thing. Main method thing shouldn't take too long. Where was I? Okay, cool. That should be it. Does anyone have any other questions for me? Okay, should be okay. Hopefully that all makes sense. If you have any other questions, just come to office hours, or you can shoot me an email or something. Yeah, no problem. Um, but yeah, this assignment will be really nice to do. I found it a lot of fun. Um, I found it a lot of fun, and it's gonna be way easier than the AVL. But other than that, you guys can head out, and good luck on this assignment. I hope you guys have a good one.